in terms of upcoming events and CFPs, we now have a CFP tracking spreadsheet. I would encourage folks to dig into it. I do know on the RustConf front, Andrew did let the Slack channel know that due to complications with working through MITRE's publication policy and timing and whatnot, sadly, it does not look like he will get something in for the CFP deadline around OmniBOR. There are too many complications involved. But I do know, for example, that we have had some ambition around getting something into Usenix. And we do have, I believe, something in the for the open source summit, for the supply chain security summit. I believe we've got a talk accepted. I should add that here. And I know that their talk has been submitted for Open SSF Day at Open Source Summit. So cool. Moving back to then Build Tool Community Outreach. Does anyone have any updates here? Okay. POX. Okay, it looks like we actively have someone typing on POX as we go here. An anonymous dolphin, which I suspect may be Barathi.
Are you still looking for a Python POC?
Very, very much would love to see a Python POC. Yes.
Can you tell me what that would mean? What are you looking for in a POC?
I'll hum a few bars here, and I would be delighted if you want to start a discussion to thrash out with various folks sort of what that would look like. But let me do the hum a few bars bit, and other people can sort of chime in here as well, because I know that the different folks have different sort of feelings on the subject, or may have different feelings on the subject. So on the Python POC, essentially, one of the things that you effectively are looking at, so Python's interesting because with Python, you have Python, contrary to popular belief, is sort of a compiled language.
Right.
In that Python does compile the PYC files.
Sure.
And so you would probably want to have those PYC files capture something equivalent to the SBOM data. We talked about something, at one point someone was talking about something like __bomb__, just because if you're going to do something Pythonic, well, obviously that has to be done with underscores, prefixing, and following.
Yeah.
But there's also the thought when you sort of look at Python as a language is Python's interesting because it's dynamically linked. It turns out that for the purposes of OmniBOR, dynamically linked is in some ways much more interesting than the usual dynamically typed or scripted lines that people look at. And the reason you sort of see this is that you have exactly the same interesting problems going on in Java, which is strongly typed, as you do in JavaScript or Python. So the idea would be something like this: make sure that the Python compiler, when it's compiling a PYC file, embeds in some fashion the OmniBOR data and outputs the OmniBOR or the input manifest. And then the second thing would be when you actually are running Python, right? So you run a Python executable, you'd like to have some programmatic way to access in that executable that you're running the current artifact dependency graph of the current running Python at any given moment. Does that make sense?
Excuse me, I've had allergies.
It's okay.
So I get the embedding stuff. You want to output the manifest, and is that correct? And would that be something that's separately executable? Like there's something you execute that would be like, spit out the manifest? Is that what you're looking at?
Well, it's probably similar to, and this is part of where a discussion is going to be helpful, right? Because there are details to be thrashed out. And while I am a long-standing aficionado of Python, it has been a few years since I've used it in anger. But if you look at for example, the current compiling tools, they output the OmniBOR manifest if and only if there's some indication, typically via an OmniBOR dir environment variable, that there's a place to put it, right? In which case you output that manifest. And then it embeds into the resulting artifacts information about what's the ID of the input manifest for that artifact. So obviously going from .py to pyc, that OmniBOR, that input manifest is very simple. But when you're actually a running process in Python, this is where it gets interesting, because a running process in Python can dynamically import things as it goes, right?
I'm not sure. It might import it all at the once you execute it.
Well, let me put it a bit differently. If I have a Python file that has a main in it, so it will actually execute, and it's got a bunch of imports. Those imports are resolved at runtime, not at some sort of build time.
Right, that's true. That's true.
And so as a result, I can't really go and grab any information about the artifact dependency graph for that main, except at runtime, right? That's the only place in time at which it's knowable.
So, excuse me. So, in some sense, and this may be naive, but does it really matter? Because if you've got an import, even if you don't bring it in for a particular execution, but the potential, but the import's there, and so at some point, if you execute one method, you might bring in an import, and if you don't execute it, you might not. But regardless, shouldn't that be part of the manifest?
Well, I would say there are sort of two things that we can talk about here in terms of imports. The first one is the first one could be classified as a runtime resolution of imports, right? Which basically means that even if I have an import up at the top of my file that will get imported every time, I don't have a way of knowing what I'm going to find when I run that file to import until I'm actually at runtime. Because there are various things I call, there's a Python path variable that can be reset that points me to different places. There's a whole variety of other tooling that can play weird change root games in terms of setting up Python environments. So that's what I would refer to as the runtime resolution piece. And then the second piece I think you're getting at is the conditional import, which I don't have as much experience with in Python with conditional imports. I'm a simple boy. I put my imports at the top of the file. Does that make sense?
Yeah, I mean, most people do. Once in a while, I find myself, embedding one, just because I'm not sure I'm going to use it, and why bring it in if you're not?
Well, and quite frankly, like I understand that it's a doable thing, and I understand that people do it. I just don't happen to have a lot of experience with it personally.
Yeah.
And so yeah, and so the real question, I guess, comes down to, and I think this is where it may make sense to sort of take it off to a discussion, because I would want to go Google some things and stick some links in, is like, what shape do we want it to look like? And what's the simplest first thing we can do to move in that direction? Does that make sense? Oh, Davis raised his hand, yes.
So I guess what I would do if I were working on this is I would do two things. First of all, I would build, I would generate Gitoids for everything that was converted from a source file into a PYC. So whatever process does that, generate the same kind of OmniBOR ID and OmniBOR docs that we're generating for compiled code, because that is compilation. For for execution, I would just emit a dynamic, OmniBOR document chronicling what was loaded when.
Okay, that sounds good.
And I think that those are they're probably in a very similar place in the code path. In other words, my guess is that to create a PYC, you're simply invoking Python. It's reading in a file. Whenever it reads in the file, great, just generate a Gitoid for that file and then figure out where it was imported from. And that creates your OmniBOR document. And Robert, if you want to like go offline with me and chit chat about it, I'd be more than happy to.
Yeah, I would like to discuss it. I'll probably want a little time so I can start to dig into it first and make sure I'm asking the right questions.
Yeah, and I guess the one sort of thing I would suggest is, to the extent that you find it a productive means of discussing it, discussions have the nice effect that they are sort of durable over time and easy for folks to participate in. So, by all means, do what works for you in terms of chit-chatting. But if discussions work for you for chit-chatting, they make it accessible for other folks.
They just want us to record it. Yeah, maybe a Slack conversations too, if you do that kind of thing, David. TPP, sorry. Yeah.
Yeah. You're muted, Dave.
Great. I made that mistake how many years into doing Zoom meetings? Robert, I'll send you communication offline. We can figure out when and how to sync.
Sounds good. Yeah.
Thanks.
Cool.
Yeah, thank you.
Awesome. So bouncing back again, I technically consider that a question from implementers. So germane for the first part of the call, Vajislav, you have something you wanted to show as a POC?
Yes, can you hear me?
I can. Would you like me to open it up so you can share?
Yeah. Sure.
Let me do that. And
just a second.
And by the way, folks, it's always in bounds to ask to share. The only reason sharing isn't enabled for everyone by default is because I haven't figured out how to enable it for everyone by default, and I keep forgetting to turn it on.
Okay, can you see my screen?
Yep.
My terminal. Okay, great. So this demo will show the recently implemented implementation of OmniBOR concept in GNU AS Assembler. The motivation for this implementation was specifically when building a Linux kernel and OpenSSL projects with OmniBOR aware GCC and BNUtils, specifically LD, didn't take into account situations where .s files generated by a Perl script, so not via any OmniBOR aware tool, didn't contain any OmniBOR information, and therefore the resulting object files also didn't contain any OmniBOR information. So to start off with, we have an a.c file, which is very simple, one dependency. It includes a.h and also all the dependencies from stdio.io.h. These comments I can explain a bit later. It is a part of another feature. I will just briefly mention it later, but we just have two regular files. So previously, when we do GCC -s, so for example, this is what Perl would do, just not use obviously GCC, but it would create an a.s, and that a.s would look something like this. So no OmniBOR information anywhere, and it will generate this directive .file a.c to specify what is the original source file. So now if we just use that .s and we try to create an object file, we will not get any OmniBOR information. That is why this was implemented. So now, if we use an OmniBOR aware bin utils with an AS, so this is my copy of bin utils and the AS tool. So if we use, it can also be used wrapped around GCC, but it is okay. So we introduced a flag called an option called -- OmniBOR. It can optionally include, for example, something like this. Obviously, by the OmniBOR spec, it specifies which directory to store the OmniBOR information in, and we can use that .s file to create an object file, right? So we get a.o and we get OmniBOR information in this dir directory. So if we want to see first of all that object file, we can use an OmniBOR aware readelf tool now, which was previously also implemented, not as a part of this one, and we can show notes because it is an elf note section. We see that .node.omnibor is now created with these gitoids. If we see what the actual OmniBOR information generated, what it is, we will see. So SHA-1, SHA-256, I will show both now, but from now on probably just SHA-1 because it's the same. We see that this 42B is this gitoid and 5CE2 is this gitoid. So the gitoids of the generated OmniBOR document files are embedded now in the object file, which was the original intent. We see in these files that we have two entries in these OmniBOR document files. Those two entries correspond to, first of all, the source file for the assembler. So that is this a.s, as you can see here. And this is 2CF1, which is this one. So this is, this is this, and the other dependency, which may not be necessary, but for now it has to be there, is this one, a.c. And this is why I emphasize this directive, which GCC put in, because assembler recognizes that as a dependency for the resulting object file. This is not probably necessary, especially, for example, if we have an a.s file taken from some other directory where it was generated, it will have this directive embedded, and a.c might not even be present in that directory. So we would have an a.c generated as an entry in the OmniBOR document file dependency list. However, it is not even present there. Actually, it won't happen because we can't find it, but it is what Baratin told me. It is a best effort model to gather as many dependencies as possible. But yeah, this stays for now. So that was it was an issue previously, but it got fixed today. So this is what we have right now. However, we also have a case. So let's just remove this and a.o and a.s. This is a situation where we use a general GCC, so not OmniBOR aware GCC, to create a .s file. However, if we decide to use an OmniBOR aware GCC and we pass a record f-record OmniBOR option, for example, same, we can use it now without dir, so because it will create that objects folder in the current directory, and we specify a.c and not dash capital S. We also want an a.s file. Now, when we see a.s, it has .node.omnibor section, also this directive, and now we have an input .node.omnibor section, and we also want an output .node.omnibor section in the resulting object file. So what was done is, if we want to assemble this right now with the OmniBOR aware, GNU Assembler, we will have something like this. So the input file is now this this input file, this assembly file, which has OmniBOR information. And when we do this, these warning messages currently have to be there. We will obviously, when it's release time, get rid of them, and we get an object file, which now should have something like this in the node sections. So this is now different from what was here previously, obviously, because now we have two OmniBOR generations, first by GCC, then by AS, and we can even see that here. So currently we have two subdirectories in this gitoid blob SHA-1. One starts with 02 and one starts with 0f. As we will see soon, this 02 is, and I can show it, sorry, this is what GCC created when creating a a.s file. These I will explain later. These are connected to those comments that I mentioned. So this is what GCC generated, and this 0206 is what it embedded in the a.s. So in this section that a.s had prior to, and I mean still does prior to compiling it into a.o, this, I mean, it's not visible right now, but this is that 0206. We also had another SHA-1, as you can see, SHA-1 OmniBOR document file generated. It is this one, 0FB0, and as you saw here, it is what a assembler generated and embedded in the output object file .node.omnibor section. It is the same thing as before, with one. So these two are the same. I mean, this is a gitoid of the a.c. This is the gitoid of the a.s. I can even show you. So see those 3, 2, 5, 1. This is the same as this, with one change. It is this bomb part, and as you can see, it extracted this OmniBOR information from the a.s that I previously mentioned and put it in the bomb part for the dependency that corresponds to that input assembly file. So this 0206 is obviously this one. So there is an added level of indirection now. The assembler OmniBOR information directs us to the real OmniBOR information generated by GCC. So this is what we have right now. Also, I wanted just briefly to show this situation. So it is clean now. What if we just set, for example, an OmniBOR dir environment variable, let's say something like this, because all these tools, GCC, compiler, AS, assembler, LD, linker, they are all OmniBOR aware. They work also when you specify OmniBOR _dir environment variable. So if we just do something like this, a full compilation without linking, because it just will complicate things even more, it's not necessary right now. So we just compile a.c into a.o with this set, we will get something like this. So we will have in the a.o we will have exactly what we had previously when we did it step by step. So this and this, it is the same here. In the resulting object file, everything is the same. And however, there is a slight difference in the OmniBOR information that is generated. So we also have both 02 and 0F. Now this one is generated by GCC, this one by assembler. So when we do this, when we we'll see that it is the same. However, the difference is in the other one, because now we don't have a.s. As you can see, so we don't have a.s. So this corresponds to nothing, because that is a temporary assembly file which was generated by GCC. It has the same hash as a.s previously, because GCC created the same file with the same contents, but we don't have it here unless we put like a save temps option.
Okay, so I do want to back up. I want to back up a little bit, if we could, to sort of the original motivation for this. So you said there was something in the Linux kernel that was the motivation for instrumenting the assembler. Could you talk a little bit about that?
Yes. Yes, because we, Bharati and I, wanted to test the GCC and BNutils as well as LLVM Clang implementation of OmniBOR. So we wanted like bigger projects, like larger projects, and we decided, and for probably some Cisco testing, we decided on OpenSSL and Linux kernel. So we downloaded the sources and then ran the build with the OmniBOR aware GCC and BNutils, and also on her part LLVM and Clang. And during the build, obviously there were some issues, those were resolved, and we got the results that we got object files, and all of them had OmniBOR information, except ones which were generated from .s files, and those .s files were not generated from some C files. They were generated using some what I think are Perl scripts. So they didn't contain any OmniBOR information, and because GCC was not used at all in compilation from those assembly files into object files, no OmniBOR information was present in object files. So we thought that definitely assembler should be aware of the OmniBOR concept and therefore implement things there. But then we also found out that if we treat it the same as GCC in terms of this environment variable, for example, it will generate that an additional step of indirection to the real OmniBOR information.
Okay, no, that sounds good. So effectively what you've done is you found that there were places where we actually had raw assembler running around loose, and so it made sense to catch that as well, as that's also part of the artifact dependency graph.
Well, yes, because if we don't, for example, if we take all the object files from the build of like Linux kernel, we will find that in some of them just there is no OmniBOR information, so there is no tracking of where it came from which files and things like that. So it is like excluded from the OmniBOR tree. So we thought that OmniBOR needs implementing in AES as well. It just needs some fine tuning also, and maybe considering what is the play here. Because, for example, if you want not to use the OmniBOR implementation in the AES, it is sufficient enough to specify the option for GCC. So -f record -OmniBOR, and then AES will just not do anything. It will copy what GCC created into the object file. But if we, for example, use environment variable, which is probably the preferred way, then all the tools, including LD and GCC and obviously AES, will be aware, and then we get a situation like this.
There's one thing that I would like to clarify. As a side effect of supporting OmniBOR for AES, what we found is there are, so when you compile a file with assembly file as input, then the case is very clear that you're only doing an assembling step for that compilation process for that GCC command. So the support is made available, and that is good. Now, the second case is when you say GCC-CA.C, you're implicitly creating an assembly file and from that creating the object file. So this is the example that he last showed, where if you can see the last line, there is a blob 32512 and then there is a bomb 02. So this 3251 is a temporary file which the compilation step, the first compilation step produced a temporary a.s, and then from that it created an object file. So this is not present anywhere. So would it be okay to produce a hash of an object that was intermittent and never exists after the compilation step completes? Because otherwise what happens is we don't have, we have to somehow find a way to see whether, you know, the assembly file that was used to produce the object file was some intermittent thing, or did it come from the source? That would be like, may not be very obvious all the times, I guess.
I mean, to me, those kinds of transient, temporary, like intermediate files are just an implementation detail, because you could easily imagine, like, I think Clang doesn't separately invoke the assembler. It just pipes, you know, it just emits object code directly without an intermediate assembler file. And so, you know, the question of whether or not it generated an intermediate file and then invoked the assembler doesn't seem very relevant from the outside of like, I wanted to take the C file and turn it into an object file.
Yes, but in our, that's what I'm saying. So unless you pass an option where you want to preserve the intermediate files, or you pass an explicit pipe command which says, you know, pipe every output of each stage to the next one, these files would not be created. But now the side effect of adding the support to the assembler is whatever was the input that it sees, it's going to record the omnivore information. And this input was transient, but the assembler wouldn't know about it, because the assembler uniformly adds support to whatever input it receives. And this input could have been from a temporary step or
yeah, so I think let me sort of see if I can sort of get a little bit of clarity here. I think what you're saying, Bharathi, is that because GCC shells out to invoke the assembler as an executable instead of incorporating that into itself, that there's a great deal of complexity in the case of GCC in being able to not have the intermediate assembly step if the assembler is actually capable of doing the OmniBOR step. And I think what Jeremy was saying is that Clang will do all the assembly stuff internally to itself, so it doesn't actually exit to a separate tool.
No, it doesn't have to be a separate tool, but then the code that does the assembly is now omnivore aware, right? It's not invoked as you don't invoke it as a.s, but GCC, you know, there is no clear demarcation between, okay, now call AS, now call, you know, now call CPP, now call AS, now call LD. There is no clear demarcation, but the code is just the common. It's just going to process the input, and when you say process this input omnivore aware, it's going to do it. Whether you invoke it from GCC or whether you invoke it standalone. And the code, the assembly code that processes, that generates omnivore information will have to know whether this input was piped from a previous step or called standalone. That okay. Intelligence would have to be implemented, or you're going to have a blob entry which does not exist in your
no, I understand. Go ahead, Jeremy.
Yeah, I mean, I think, like, historically, there's always been a distinction between little.s and big.s files, where little.s are intermediate files generated by something else, and big.s is like hand-coded assembler. And I wonder if, what am I saying? Like, this kind of ties into the question of like whether or not tools should always be generating OmniBOR information just because they see an environment variable. Like, I do think in this case, if the assembler is invoked by GCC, it should not be doing its own OmniBOR stuff, especially since GCC is perfectly capable of injecting everything it needs to into the assembler itself by creating the section itself. So,
could I make a suggestion? No, please go ahead.
Sure. I just my thought. I think this definitely fall into the category of implementation detail. I mean, it should be the tool specific, right? Each tool can decide how it will handle this kind of case, right? For example, GC can handle this way and Cloud can handle the other way. It should
The
be
high
fine, I
level
think.
question is, the high level question is it, if we think that, you know, consumer scripts that we definitely don't want an entry which does not exist, then we'll have to find a way to implement it that way. Now the question is, would this be,
So
this kind
I
of a
think
generation be?
take another example. For example, when you do the GC -O without -C, right? -O accessible directly from .c file. Actually, the .o file is just an intermediate file. You don't see it actually at the end, right? But still, right now, I think you still generate that .o file as one intermediate,
yeah,
node, right? That's a similar, same case, I think. So
I agree. Like, I think taking a step back and looking at this from a sort of like OmniBOR first principles point of view, we're kind of talking about artifacts that don't exist in the, like if you have the dependency graph, you have an invocation of a tool to take some inputs and produce an output. But then that output is referencing artifacts that exist nowhere else in the dependency graph. And so like, it seems reasonable to me that if you're going to have if you're going to reference an artifact in a manifest, it should exist somewhere in the dependency graph. And so in one sense, you could see the object files, like of a regular build process, the object files are, you know, implementation details of the overall build process, but they're at least visible in the dependency graph as intermediate artifacts between the inputs and the outputs. But if they're ephemeral artifacts entirely within the scope of a single tool invocation, they shouldn't be mentioned because there's nothing you can do with them.
So, I mean, my general thinking is, I think Young Kui's point about this being somewhat of an internal decision of the tool vendor was somewhat apropos in that it is the tool producer. That said, I think what Bharathi's really looking for is a sense of what's a good idea here. And I think getting to your point, Jeremy, what you're sort of reaching for is there a heuristic to offer advice to implementers in this regard? Would that be a good characterization of what we said so far?
Yes. Yeah, more precisely, having non-leaf artifacts in the graph which do not exist. The leaf artifacts exist, the non-leaf artifacts.
Yeah.
The .o file is also a non-leaf, right, artifact. And sometimes you don't see it at all during our GC build, right?
So really quickly, I think Dave Pollock has had his hand up for a bit.
So I think this actually goes back to the Python discussion that we were having with Robert. So imagine if there is an eval done in Python or JavaScript, or in the case of the JVM, you dynamically load some bytecode in. You're dealing with like aspect-oriented programming or something. That stuff is ephemeral. But I would argue that you actually want to capture the gitoid of something being evaled, even if you don't have the original source. Now, why would I do this? I'd be interested to see a code path that evals something. Does it eval the same thing over and over again? Does it eval a different thing every single time? Is there a pattern change in eval? In other words, if I can say 80% of evals are the same, but 20% are different, all of a sudden you move to 70% are the same and 30% are different, that could indicate some behavioral thing in the system that we care about. So at least from my perspective, being able to capture the gitoid of an intermediate artifact without actually capturing that artifact itself has some value. And I think we will see more of the value as we go into runtimes that are more dynamic. Feel free to throw things at me, Jeremy. My guess is you're like, dude, you're so wrong, and here's why.
I mean, usually those intermediate artifacts, they actually exist during your build. It's just in the temp directory. You see a temp file generated and then finally eventually deleted. So they still exist temporarily, right? For that file. So say in that case that they are valid.
Yeah,
So
if
I would
if
like
I
to
could,
that too.
if I could just put a little bit of precision around our language here briefly on this whole notion of files which exist. I don't think the existence is so much the thing, as you pointed out. They tend to exist. But this is back to the sort of point that you were making, Jeremy, about them being ephemeral. And so the real question is these are I would suggest that we talk about files that are persisted after the build step is complete, rather than whether they exist or not, because that can be very hit or miss. Does that make sense?
I mean, I think from an OmniBOR perspective, a file doesn't really exist unless it appears in the dependency graph. And like, you know, there's an infinite number of ephemeral files that could be created and destroyed, but if they're never actually observed by the OmniBOR process, then they don't really exist. And so the situation we're talking about here is we're kind of capturing one of these ephemeral files in the manifest, but in such a way that we can't really do anything with that information because what we're seeing is not a like if we represented the whole GCC invocation process as a whole chain of tool invocations, like if GCC itself generated a chain of separate manifests with separate intermediate artifacts for each of its internal steps, like the front end generating assembler and then invoking the assembler and then generating the object file, then that would be fine. Like from an OmniBOR perspective, that's completely self-consistent. But what we're seeing now instead is an ultimate artifact saying, I'm referencing this transient an ultimate manifest that is saying, here I am referencing a transient artifact that never really existed. Like it's not the output of any build process or build step that you saw. It's just one that happened internally. And like, there's not much you can do with that. And to a certain extent, I agree with you, DPP,
So maybe
this is similar to the dynamic case in that it's hard to know what it means to see these things dynamically.
I would go back and say, and this is back to where there's a distinction between guidance and requirements on this from the OmniBOR point of view. I think it's actually relatively important to maintain the sovereignty of a build tool in making the ultimate decision as to what it considers to be part of the artifact dependency graph, because we've got a lot of people here who have seen a lot, which is really valuable, but we've all seen enough to be a little bit humble about it, right? And realize that people are going to come up with interesting and smart approaches to things that we don't yet envision. So for example, I've had a number of conversations with people about whether or not there would be anything interesting in collecting various transformations of intermediate representations in the LLVM case. I'm not entirely convinced that it's useful, but I'm not entirely convinced that somebody smart couldn't do something interesting with it either. So I wouldn't advocate for doing that now, but I wouldn't want to rule out someone doing something smart in that direction in the future. I do want to actually make a suggestion here. I think this is an excellent discussion that we've had here. Could someone, whether it's Barathi or Jeremy or Dave Pollack or whoever, but somebody take the action item to go and start a discussion on the GitHub? Because I think there's a lot of interesting stuff to thrash out here. and then we can look and see, sort of what we would like to actually cover in the remaining 10 minutes here before we move on. This has actually been kind of an awesome tools call. I know we've sort of had you moved away from oscillating back and forth, but there's been some interesting stuff happening in the tool space here, and I'd like to continue the discussion because I think Bharathi would actually like some guidance, but I think we're not going to settle it here, and I do want to make sure we have some space for other stuff.
I'll open an issue. I just wanted this discussion to be like after it's concluded, then I will begin the implementation on the Clang LLVM side. I didn't want to have multiple implementations without the spec agreed upon. So that was the reason why I brought this discussion.
So I would say from the, and again, we can hash this out in the discussion, from the point of view of the spec, I wouldn't expect the spec having a hard and fast prohibition on this, but we may have guidance to help implementers figure things out that may go one way or the other. Is that fair to sort of your position, Jeremy, and your position, Dave?
Can I actually state something? And I know you want to move on, but I guess the rule that I would use is every single Gitoid, or I'm sorry, every single document, OmniBOR document, has to be traceable to a file that can either be presented or witnessed.
Ooh.
And even if there are intermediate representations which cannot be either presented or witnessed, as long as you can get back to something that was, it becomes the tool implementer's choice. And when I say witnessed, I'm talking about a zero knowledge proof that a particular file existed and it did have that Gitoid. And as long as we can do a zero knowledge proof, which is the witness of something or the actual presentation of an open source file, and when I say presentation, I mean durable, there is a URI to it. Does that feel about right, Jeremy? Does that split the baby in kind of a jigsaw puzzle way that suits you?
I mean, I think that's kind of capturing the same thing idea that I was trying to get at, which is that like every file that's mentioned in the manifest has to have some sort of basis. Like you have to be able to yeah, I think it's another way of phrasing what I was getting at. And also note that my sort of input tagging proposal also kind of helps reconcile this, because if you can tag those transient files as being transient, so whoever's analyzing the manifests could see, oh, this is a transient thing that I might not be able to, that I could strip out if I'm not interested in, then the fact that it's present in the manifest to start with is not all that important. It's only really the case where what gets put into the manifest at creation time is all you can ever use, that these questions become fraught.
Okay, so really quickly, we've got a few minutes left. I see in the chat, Frederick brought up a real world news item that might be good for us to be aware of, which sounds like a good 7-minute sized thing. As we're moving towards the close of the call, do you want to post a link in here and tell us about it, Frederick?
Sure. Actually, I sent you the link if you could post it because I'm on mobile.
Sure.
But in short, there was a federal agency, which happened to be CISA, that was hacked by two various groups, at least two groups, over a patch that was over 4 years old. So there was a CVE in a tool inside of a tool they used that had a 9.8, and their scanners failed to pick it up. One of the reasons that people are going to want to move towards OmniBOR in the long run is going to be because of the failure of scanners in terms of what they put on, or what they in terms of what actually goes into it. So I know this is preaching to the choir here. This particular one failed because they did not happen to put the directory in. They installed it to a non-default location and then never updated it, and the scanner was not configured for that environment. But we also know that the scanners are themselves, even if it had scanned it, perhaps it caught this one, but what other pieces of software are out there that the scanners are not picking up because they don't meet some fingerprint or some hash. And so one of the things that I think would make sense would be to collect these type of things where we can show various real world impact and that we could possibly prevent, and also to possibly get us moving towards the concept of what do we want to do about how do we want to integrate with inventory systems where these type of systems should not be ever installed bespoke, but even if they are, having a way to easily find and inventory these particular systems would be of great value. So in short, that's so I believe Ed posted the link on there for your own reading, but just wanted to point like this particular one out, that there's some interesting attacks that have hit the news recently that our solution here can definitely help with. I
Cool.
stunned
No.
everyone to silence.
Well, I mean, not in the surprise sense that this kind of a thing is to be expected, but I'm glad to see that it's getting some coverage. I think some of the euphoria on the scanner front may be wearing off.
Yeah, and I think part of what we could do is, so there is a supply chain thing, but this particular one was straight up lack of patch management, and I think part of it is if we start collecting some data on the types of attacks that we see publicly announced and post that into a Google Doc or maybe on the OmniBOR webpage, although that's a little bit more risky because companies don't like to have their names plastered on things when bad things happen. But I think we should have somewhere that we can keep track of some of these kind of pieces of attacks as they come around, and that gives us a little bit more data. Is like, if we wanted to protect this particular one, does OmniBOR have a place for it? And if it does, what is the shape of that particular thing? And so it gets us into the ability to ask that in a more systematic way rather than us coming together and talking about it, but also gives a path where people who are not as in tune with our community are able to start to see like here's a list of attacks. Here's how OmniBOR could have mitigated those particular attacks or surfaced the risk earlier. Like trying to drive it towards something a CISO would love to see is my thought process.
Yeah, and I'm thinking, delving into the details here, like this definitely relates to the dynamic code case because it seems to be .NET. And so like my understanding is that the .NET runtime environment is very similar to Java in that it's a like runtime assembly of existing artifacts. And so in practice, in order for OmniBOR to be useful here, would it have to be built into the CLR itself? In order to be able to sort of record these artifacts? Or is there some other step in the process where you could insert OmniBOR and it would be able to capture the stuff?
So
given that we're talking about an environment that's already kind of mismanaged, so you need to make it so that it would be something that's on by default.
Tell us what you really think. So I apologize, I don't know the CLR very well, so I'm going to reason by terrible analogy to Java because I do know Java pretty well. And on the Java front, I think what we basically discussed had been adding something like annotations to class files. And then in Java, the thing that actually does the loading is a class loader. And so the class loader sort of keeps track of the things that it has loaded. And so it would be the natural entity to ask these questions to. Since you can bring your own class loader to Java, I don't think you would intrinsically have to go and insert yourself into the runtime proper to be able to do this with Java, but I don't know if that's true for CLR.
But in Java, if you can bring your own class loader, then everyone will bring their own class loader. And so unless they're composable, if you have a class loader that supports OmniBOR and you bring your own class loader that doesn't, you're not going to get any of the OmniBOR support.
There's definitely some things to be worked out and thought through there. I agree. But there are some interesting corners in there. I think generally speaking, and keep me honest here, Dave, but is it true that class loaders in the generic tend to derive from a common class loader up tree in terms of the object tree?
Yeah, there's a core class loader, which is the thing that actually takes the stream of bytes that has been munged by, inspected and munged by previous class loaders, and loads that actually into the JVM. I don't know if you can do any AOP on it, aspect-oriented programming, to intercept that method. You know, I'm not sure whether it's actually baked into the JVM or whether it itself is loaded. So if you could load something before it, you could actually intercept. There are also plugins into the JVM that I believe you can intercept something underneath the class loader. I can look into that. Let me just make a note. And, you know, once again, I don't know the analogy to the CLR, but maybe some of our Microsoft friends can point us in the right direction.
Yeah,
Yeah, I think we actually, go ahead.
Yeah, but before we finish up, it's also important to not discard the what actually gets serialized and stuck on the file system as well, because anything that's loaded, you're entirely right. We don't ultimately know what ends up in the CLR in terms of what it looks like, but they still have a source coming from somewhere, where that source happens to be some DLL or some object that is being loaded from the file system somewhere. And so those, so there may still, even though it's limited, there may still be some connection there that we could tie in as a low-hanging fruit while we work out the harder problems.
Yeah, it may also be worth, if someone wants to start a discussion on this. I know that we have a contributor who has contributed a C# set of OmniBOR libraries, and adding them into the discussion may bring someone who actually knows something at that level of depth. The other question I wanted to ask is, I never quite pinned down, who's going to start the discussion on the assembler stuff? Would you be willing to do that, Bharathi?
Yes, I will do that.
Thank you so much. I appreciate it. We are at time, and I want to be respectful of folks' time. So thank you all. I think this has been fantastic. And we'll talk again next week.
Bye. Thank you.